Greetings to all you exquisitely inquisitive ladies, gentlemen, and scholars. Today on Philosophy Naturalis, I would like to share with you how to utilize the skill we learned in the previous episode in an actual calculus problem, in which we will be finding the absolute max and absolute minimum points of the function y equals 6x to the 4/3 minus 3x to the 1/3 on the interval -1 to 1. The first thing we'll need to do is find the derivative of the function. And so, as what is naturally done when taking a derivative, is we brought the 4/3 down in front of the x in order to be multiplied by the 6, and then we simply subtracted 1, or in this case 3/3, from the original 4/3, and also we brought the 1/3 in front of the other x in order to be multiplied by the 3, and we subtracted 3/3 from the 1/3. Once that process is complete, this is what you should come up with. And now here is where we get to put to use what we had learned from the previous video, how to factor out negative exponents. First, factor out the smallest of the two exponents, which is x to the -2/3. And so now you shall subtract the -2/3 exponent from the 1/3 exponent, and that will give you 1 as shown here. Now that 1 becomes the new exponent of the 8x. And in case you were wondering, this 1 here is simply the invisible one that was in front of the x to the -2/3 that we had factored out. Now we can make the 2/3 positive by sending it down into the denominator, giving us the completed derivative of the function 6x to the 4/3 minus 3x to the 1/3. Once finding our derivative, we must find what are called the critical numbers, and this is accomplished through setting our derivative equal to 0 and solving for x. As you can see here, we will first bring our denominator, the cube root of x squared, over to the right side in order to be multiplied by 0, which will of course equal 0, bestowing to us our first critical number of x equals 0. From here we bring the -1 to the right side, transforming it to a positive 1, and from that we divide both sides by 8, making our second critical number x equals 1/8. Remember now that our ultimate goal in all of this is to find the absolute maximum and minimum points of our original function. To do this, first we must evaluate the critical numbers we had just found through finding the derivative of the function and setting that function equal to 0. Hopefully you didn't forget that already. We evaluate the numbers by plugging them into the x variable of the original function. Secondly, we will evaluate the endpoints of the interval that were shown at the outset of this video, the endpoints being -1 and 1. And so these points are also evaluated by being plugged into the x variable of the original function. Here we have the 4 numbers that must be used in order to find the absolute maximum and minimum points of our function. These are the numbers that we will be plugging in to the x variable of the function. As can be seen here, when we plug -1 into x, the y variable is 9. 0 into x, y becomes 0. 1/8 into x, y becomes -9/8. And 1 into x, and y becomes 3. The largest number is 9, and so that is our highest point on the graph. Ergo, 9 is the maximum. -9/8 is the smallest number, so it is the lowest point. Ergo, it is the minimum. And there you have it. The absolute maximum point is -1/9, and the absolute minimum point is 1/8, -9/8 of the function y equals 6x to the 4/3 minus 3x to the 1/3. And so that concludes this episode of Philosophia Naturalis. If you have any questions or suggestions, by all means, leave a comment. And if you like this video, give it a thumbs up and subscribe for more.